Okay, so we've got a vapor compression refrigeration cycle using ammonia. Okay, and it exits the evaporator, enters the compressor at negative 22 degrees Celsius, saturated vapor, so the quality is 1. Okay, then it gets compressed to 16 bars at 160 degrees Celsius, goes through the condenser, and exits at the same pressure with quality of 0. Okay, I know the refrigeration capacity is 150, and of course the refrigeration capacity is what goes through the evaporator, which is state 4 to 1. Okay, I want to go ahead and find the power input of the compressor, 1 to 2, and the coefficient of performance. So as with most problems, I go through and I set my states. So this is ammonia, negative 22, saturated vapor, so I start right in here, and I have negative 22, saturated vapor means 1415.08. Or I'm sorry, 1514.08. Wait, let me double check. No, 14. I was right the first time. 1415.8. 08. Oof. So 1415.08. Excuse me. So 16 bar, 160 degrees. So I'll probably be up here. Okay, so it's 16 bar. I'm in this guy right here, 160 right here, so H is 1798.54. So 1798.45. I said that backwards. My mouth isn't working right, so 0.45, that's right. Okay, so then 16 bar saturated liquid. I go back into my saturation table. So I'm at 16 bar, which is down here. Saturated liquid, I get 376.46. So 376.46. Now this is the expansion valve, so H is constant across that, so I very easily set my states right here. The pressure here is going to be the same as the pressure at 1, though I don't really need that. Okay, so in order to find the power input to the compressor, the first thing I need to do is find my mass flow rate, and I can do that using the refrigeration capacity, right? Which is essentially Q in, which is 150 kilowatts, equals the mass flow rate times H1 minus H4. And again, this is the performance of the refrigerator. This is what's going on. This is what's cooling that space. Okay. Anyway, from this, knowing H1 and H4, knowing the refrigeration capacity, I can find the mass flow rate to be 0.144 kilograms per second. Okay. Now that I have that mass flow rate, I can go ahead and figure out the power input to the compressor, which again is 1 to 2. So the input is that mass flow rate I just calculated times H2 minus H1. Again, I know H1, H2. I now know my mass flow rate. I can very easily calculate the work to the compressor, which is 55.4 kilowatts. So that's how much power is supplied to the compressor. Okay. Now the coefficient of performance, beta, of course, is output over input. And again, my output is the refrigeration capacity, Q in, which is 150. My input is the work to the compressor, W in. Therefore, I get 2.71 to be the refrigeration, or the coefficient of performance. Okay. So again, as with every problem, go through, set your states. Once you have your states, figure out your mass. Here I do that knowing Q in, okay, and knowing my H's, I can find mass. Then I can find the work to the compressor, and then I can find the coefficient of performance.